Welcome to The Explainer. Today we're tackling something that sounds a bit technical, but trust me, it's absolutely critical for any digital product: capacity estimation. You can think of it as trying to predict the future, and, well, getting it right is pretty much everything.
Yeah, I'm not kidding. Before you even write a single line of code, you have to make this super high-stakes prediction. Get this one thing wrong, and it can literally make or break your entire project before it even gets off the ground.
And the stakes here? They're huge. If you guess too high, you're just burning cash on servers and resources you're not even using. But guess too low? Well, the moment your app gets popular, your users are staring at a crash screen. Not a great look. Okay, so let's really define this challenge. What exactly is the problem we're trying to get our heads around here?
At its heart, capacity estimation is all about moving from, a wild guess in the dark to a really educated forecast. It's the process that makes sure your system is actually ready for your users from the second you launch.
And we do this by looking at four main pillars. First, there's traffic. That's just how many people are using your site. Then, storage, all the data they're creating. Next up, bandwidth. That's the network they're using to connect. And finally, compute, which is just a fancy way of saying the server horsepower you need to make it all work. Now, I want to be clear. This isn't some abstract thought experiment. It's a fundamental step in the whole system design process. You figure out your requirements, then you do capacity estimation, and only after that do you start designing the architecture. It's that important.
All right, enough theory. Let's get our hands dirty and actually run some numbers. We'll walk through a real-world example, and we're going to start with the most important pillar of all.
So the first question we have to ask ourselves is, how many people are actually going to use this thing? I mean, really. Because this one number, it drives everything else we're about to calculate. Okay, let's throw out a number. Let's say we're hoping for 1 million daily active users. And maybe each user makes, about 20 requests a day. Clicking around, loading pages. That gives us 20 million requests in total. If we break that down, it averages out to about 230 requests every single second. Seems simple enough, right?
Well, hold on. This is where things get really interesting, because users don't just trickle in nice and evenly all day. No way. They come in waves. So we have to plan for a peak load, which is often something like 5 times higher than the average. Just think about it. When are people most likely to be on your app? Lunch break? Right after work? That's your peak. And in our example, that means our system suddenly needs to handle over 1,000 requests per second, not 230. And that right there, that is the absolute core challenge of system design. If you only build for the average, you are literally designing your system to fail the second it becomes successful. You have to build for the peak. Okay, so we've got a handle on our traffic. Now let's tackle the next piece of this puzzle: storage. All those users are generating data. How much space is that all going to take up?
So if we figure that each of those 20 million daily requests creates some kind of new record, a post, a like, whatever, we'd need over 7 terabytes of storage. And that's just for the first year. That is a massive amount of data to deal with.
And getting this number right is so critical. Why? Because it hits your budget, it defines your entire backup plan, and it directly affects how fast your system can pull up data when a user needs it.
All right, next up, bandwidth. You can think of this as the size of the pipe that all your data flows through. We need to figure out how big that pipe needs to be to handle all those requests without getting clogged up and slowing everything down.
And the way we figure that out is pretty straightforward. We take our peak requests, remember that's over 1,000 every second, and we multiply that by the average size of whatever data we're sending. That simple bit of math tells us exactly what our network needs are so we can avoid those super frustrating bottlenecks.
Because here's the bottom line. If you don't have enough bandwidth, your system slows to a crawl. Users get that spinning wheel of death, they get frustrated, and they might just leave and never come back.
But, a good estimation does more than just calculate what you expect to happen. A great estimation goes one step further. It actively plans for the unexpected.
So let's do the math on servers. Our peak traffic is around 1,150, let's just say 1,200 requests per second. If we assume a single server can handle about 300 of those, the math is simple. We need exactly 4 servers, on paper. But this is the real world. We would never deploy just 4. We deploy 6. Why? That extra 2 gives us what engineers call headroom. It's a safety buffer. So if we get a sudden, unexpected spike in traffic, we're covered. Or, and this is just as important, if one of our servers just fails and goes offline, the others can pick up the slack, and our users won't notice a thing. And look, this isn't just some theory for a made-up app.
This is exactly how the biggest, most successful tech companies on the planet operate every single day.
And what's so cool here is seeing how each of the giants tunes this process for what they do. Google, for example, is obsessed with massive global traffic patterns. Amazon, they're all about planning for those huge seasonal spikes, like Black Friday. And Netflix, for them, it's all about bandwidth, right? They live and die by their ability to stream high-quality videos smoothly.
You know, the best way to really get this is to try it yourself. Seriously, take a minute, pick an app you use all the time, a chat app, a social media app, anything, and just try to run the numbers. How many users do you think it has? How much data are they creating? How many servers would you need? Give it a shot.
Because at the end of the day, look, nobody has a crystal ball. You can't perfectly predict the future. But with smart capacity estimation, you don't need to. The goal isn't to be perfect. The goal is to prevent a surprise. It's about having that strategic foresight that keeps your system humming along, keeps it reliable, and most importantly, keeps your users happy.